Okay, I have a couple more ideas. I think I'm still in 1.4, maybe even back in 1.3. Here's a line. Look at this. This is a couple things I might have skipped over here last. Here's a line. It's such an easy line that students get confused, maybe, sometimes. My main formula that helps me with lines is this y equals mx plus b. I mean, does this formula even fit this thing, or does this thing fit this formula? I mean, this just looks weird to me. Yeah. See, that's what. So I don't think you really want to say that x is 0. But you might want to say that m is 0. Yeah. The slope is 0. And if the slope is 0, then it doesn't even matter what x is. That whole thing's 0 plus b, and I guess my b is 5. This is funny. Watch this though. I don't know. I'm confused. I'm going to plot some points. Watch. This is weird. Watch. Hey, if x is -2, let's plug it in and see what we get. What do we get for y? So thank you, 5. I mean, I'm trying to plug in x is -2. I know that there's kind of nowhere to plug it. There is no x's. Anyway, so what's y? 5. All right. Well, wait a minute. What if x moves? What if x is a 0? What's 5? What's y? 5. What if x is a 1? Y is a 5. So this is kind of weird, but what you end up realizing, perhaps, is that y equals 5. Y is stuck on 5, and x kind of moves however it wants, but y is stuck on 5. We have a slope of 0, which means we don't rise at all. What we have is a horizontal line. So here's y equals 5 is a horizontal line. I'm going to write those words, horizontal line. And because he's so simple and horizontal and easy that he can confuse students. Students can get confused. He's so simple, you get kind of confused. You're used to a y-intercept and a slope. Well, technically you do have a y-intercept and a slope. What is the slope? 0. The slope is 0 on a line like this. The slope is 0. If you think of that as rise over run, you can think of it as it rises 0, but it runs whatever it wants to. I mean, it rises 0, but it could run 1 or 2 or 3 or 4. It can run whatever it wants. It runs all over the damn place. But it rises 0. And 0 over a number is 0. So its slope is 0. Slope is 0. He's a horizontal line. He looks like this. I mean, what I think my advice to students is you kind of throw all this together. This is all synonymous, okay? A slope of 0 is a horizontal line, and his picture looks like this. And his equation looks like this, which is y equals a number. See, what if he was up at 6? What would be different? But what would be his equation? Y equals 6. What if he was down here at 1? He'd be y equals 1. So y equals a number is kind of a boring line. He's just a horizontal line with a slope of 0. Y equals any number is a horizontal line with a slope of 0. And so maybe you just kind of memorize that, because even though it does kind of fit the formula, it's a little weird. Here's another one. X equals 3. Do you know what that is? You go over on the x-axis to 3, and it looks like x is stuck on 3, and it kind of looks like it doesn't matter what y is. And so this is a vertical line. It's a vertical line. X is stuck on 3. He looks like this. That's his equation. That's his picture. That's the word. But what is his slope? And his slope is undefined. And that's the proper answer. What is his slope? His slope is undefined. I can explain it if I say it's rise over run. And you could think like this guy rises a lot. I mean, you could say he rises 3, or he rises 6, or he rises 7, or whatever he rises. But watch this. How much does he run?
0.
He runs 0. And anytime you have a number divided by 0 in mathematics, that's illegal and it's undefined. A number divided by 0 is undefined. So if his rise over run is thought of as a rise of something over a run of 0, it's a vertical line. He has a slope that's undefined. And he doesn't really fit this formula business at all. So I would he's a special little vertical line. I would sort of memorize him. Hey, by the way, is he a function? Is he a function?
That one is a function.
This one's a function? Because it's a function if it passes the vertical line test. Does a vertical line only touch this once?
Yeah.
Okay, then it's a function. What about this one? No, it fails big time. I mean, how many times does this vertical line touch it? Thousands, right? So this is technically not a function. It's a funny little vertical line. And that's his equation. And if he was moved over here at x equals 2, his equation would be x equals 2. If he was over here at 10, it's x equals 10. All right, here's another idea. Look at these. Here's 3 lines, and I want to graph them as fast as I can. Y equals 2x plus 4. Y equals 2x, and y equals 2x minus 3. Okay, I'm going to graph them all right here as fast as I can. Let's start with the top one. What's the y-intercept?
4.
4. Thank you very much. And what's the slope? 2. So I should go up 2 over 1. Okay, thank you very much. There's this line. You guys okay? I just, as quickly as I could, I graphed that line. It had a slope of 4 and it had a y-intercept of 4 and a slope of 2. So I started there and I went up 2 and over 1. Hey, what about this line? Where's the good starting point? Where's the y-intercept?
0.
Oh, the y-intercept is 0, but I still should go up 2 and over 1. And if I draw that line, there it is. Sorry. What about the next line? Bless you. The next line has a y-intercept of -3, and it has a slope of up 2 and over 1. So if I draw that line, all right, this ain't the best picture. Sorry about that. But what would you say about these 3 lines? Thank you. They're parallel. Is that what you would say? They're parallel. I'm sorry, the picture didn't come out too great. It's not bad, though. But it's really kind of obvious. So we just learned a concept. What is the concept?
Same slope as parallel.
If they have the same slope, they're parallel lines. And maybe that's a huge concept. Maybe it's an idea you never thought of before. But I tell you what, it ain't a very difficult idea. If both lines, if they're rising and running the same, if they have the same up 2 and over 1, I don't know. Yeah, they're obviously parallel, don't you think? If lines have the same slope, they're going to be parallel lines. So that's an idea. And I tried to illustrate that idea real quickly. But now I want to sort of just state that idea. So you're right, parallel lines have the same slope. So what's different about them, I guess? I guess they got different starting points or different y-intercepts. Again, what if they had the same y-intercept and the same slope?
It would be the same line.
It's basically the same line. It's right on top of each other. If they have so then it's the same line. But different y-intercepts, same slope would be parallel lines, right? Parallel lines. Okay, parallel lines have the same slope. Big concept. Hey, what goes with that then is the concept of perpendicular lines. Perpendicular lines, and those meet at a right angle or a 90-degree angle. Perpendicular lines have slopes. I'm going to say it like this. They have slopes that are negative reciprocals of each other, that are negative reciprocals of each other. My ink is fading here. Perpendicular lines have slopes that are negative reciprocals of each other. That means if one line has a slope of 3/5, a perpendicular line would have a slope of almost good. The reciprocal would be 5/3. The negative reciprocal would be negative 5/3. Right. Negative reciprocals of each other. Let's just try another one. If one slope was 2, the other slope would be the negative reciprocal. What would that be? The reciprocal of 2 would be, well, it's like 2/1. So the reciprocal would be 1/2. But it needs to be negative 1/2. Are you guys okay? If you find two lines that have these slopes, those lines will be perpendicular. Right. Let me try one more. If I had, what if I had a slope of 0?
No, you can be undefined. If a slope of 0 wouldn't be the only way to have the other one be undefined.
So there's a couple ways to think, but you might be thinking visually, you might say, wait a minute, a slope of 0 is horizontal. So the reciprocal, or the perpendicular to that would be vertical. And if you're vertical, the slope is undefined. Maybe that's how you came up with it. Or maybe you thought about reciprocating a 0. Reciprocating a 0 would be putting like 1/0, and that would be undefined. However you thought about it, you are right. I mean, this is kind of a weird one. He's horizontal and he's vertical, so they're perpendicular. Okay, so now that's good. I mean, those are, you guys didn't seem like you need these couple of concepts. Parallel lines have the same slope, perpendicular lines have this. And now I can ask you, let's do one of these questions. Find the equation of the line. We've practiced this a lot today. Find it, but here's another one. Find the equation of the line that goes through, I'll give you a point. I'm going to give you a point, -5, 4. And I'm going to tell you that it is parallel to this line. 2x minus 5y equals 14. Running out of ink. When I run out of ink, class is over. Don't worry, I got backup blue. This is cool. Find the equation of the line. Listen, I'm recalling what I learned today. What I learned was when someone says find the equation of a line, I'm kind of attached to that point slope formula. I kind of think I need that point slope formula, which is y minus y1 equals the slope times x minus x1. Anyway, if I had a slope and a point, I would be good to go, you know? That's what I'm thinking. Did they give me a point? Oh, they gave me a point, no problem. They didn't really give me a slope. Damn, I wish I knew my slope.
You do.
I sort of do. They said it's parallel to this line. So if I knew his slope, then that'd be my slope. Right? So how do I figure out his slope?
Solve for y.
Probably should solve for y. If I put him in y equals mx plus b, then I can see his slope. Are you guys okay with that? I mean, at the moment, I can't tell what his slope is. But if I solve for y, you're right. Move the 2x over. It would be a -2x plus 14. You got to do your algebra correctly. Divide by -5. Y would equal -2 over -5x. I'm dividing by -5. 14 over -5. All I really care about is his slope. What is his slope?
2/5.
It is 2/5. The negative signs cancel, and his slope is 2/5. And my line is parallel. So if my line's parallel, what's the slope of my line? 2/5. So my slope is 2/5. So here I go. My slope is 2/5. I got a point and a slope. Here I go. Y minus the y value. Where's the y value? 4 equals the slope, 2/5, times x minus the x value, -5. You guys with me? A point slope formula. You need to kind of have it memorized, I guess. Ready to use. Tests and quizzes. Yeah, cool. We're done, except I'd like to clean these up. This is y minus 4 equals 2/5 x. That's a positive 5. When you distribute the 2/5 times the 5 cancels. I think I get a +2. You guys agree? Okay, awesome. One more move here. I'm going to add a 4. I'm going to add the 4 over there. So y equals 2/5 x plus 6. This is the equation of the line they're talking about. This is the equation of the line that meets their requirements. This is the equation of the line that goes through that point and happens to be parallel to that line. We took that information and did what we needed to do to get his equation. And how would this problem change if this word changed to perpendicular? What would change in this problem?
You would do -5/2 as the slope.
Good. You would still do the same procedure. You would find his slope, but you wouldn't use his slope if it ain't parallel. If it was perpendicular, you would use his negative reciprocal over here. You would use -5/2. Right. But then you'd have a perpendicular line that meets their requirements. Yeah. Good. Okay, good. All right. You guys, we're doing real good. Let me, I got a few minutes here. I'm going to go a little further here. I want to, the end of this chapter 1, then we got to get into chapter 2 a little bit next week. But I'm really trying to tell you the meat of this sandwich is this 1.2, 1.3, 1.4. I mean, that's where we've been for a couple days, and maybe you've been sitting here. There's a lot of good stuff in there, a lot of good important stuff. My test is full of that stuff. As chapter 1 winds down, there's a few other minor points here that we need to talk about, and then there's probably some good stuff in chapter 2. But let me show you something here. If we move into 1.5, it says we're solving linear equations. Well, this is where can you solve a linear equation? Can you solve for x? Now listen, this is the easiest thing we've ever done, actually. I mean, I don't even consider this part of this course, okay? And when you go to 1.5, you're supposed to solve linear equations. I feel like you came into this class knowing how to solve linear equations. So I don't really enjoy doing this. I like more practical math. I like more useful math. But anyway, you probably have to do some homework on my math lab. I probably assigned some of this homework. So you probably have to do a little bit of this. Let's just do it. I mean, how do you solve for x? We've been already doing it in little equations. This is just a bigger version. I guess you would distribute things, collect like terms, get x by itself. I mean, you know how to solve for x, I guess. I'll help you. Distribute the 3x minus 3 plus 2x. Distribute the 5, 15x plus 40. Gather like terms together. I would kind of call this 5x minus 3. Do you guys agree? Mm-hmm. Over here it's 15x plus 40. I tend to try to get all my x's on one side and all my numbers on the other side. I mean, that's what we're supposed to do. Maybe I'll just move the 5. I'll subtract the 5x over here. That'll give me a 10x on this side. Is that okay with you? And then when I move the 40 over, I'm going to subtract 40 over here. So what's over here? Negative 43?
Yes.
And one more move. Divide by 10, and x is negative 43 tenths. Right, you could call that negative 4.3, but we solved for x. We solved the linear equation. Again, you could do some homework, but I don't think you'll see a test question like this. I don't think you'll see a test question like this. But have I asked you to solve equations? See, earlier today, I wanted to know when my car was going to be worth nothing. Remember that? And you had to, that was a word problem, but you had to set it equal to 0 and solve a little equation, didn't you? But so I like solving equations when there's sort of a meaning to it. Not really when you just, hey, just solve this. I mean, I need some of that. We need some skills, but I like to solve if there's a meaning to it. Like, we need to find the X-Intercept, or we need to find out when my car is worth nothing, or we need to, you know, so I put it more in that context. So one idea that comes up in 1.5 is this. They call it the zero of a function. They use the word zero of a function. And I'm going to tell you what that is. It's the x value that makes f of x equal 0. But we're using this function notation, and I'm using this new word called the zero of a function. But I wonder if you can read what I just wrote on the board, and I wonder if you can put this in other words for me. I'm saying it's the x value that makes the function equal to 0. I mean, that's what a zero of a function is. It's the x value that makes the function equal 0. Can you think of another name for that? Or is that something we've done already? The word is new, but is this something we might have done already? That's actually the X-Intercept. It's the X-Intercept. It's the, hang on, what is it? It's the x value that makes y equal to 0, right? I can call that y, can't I? It's f of x. So when y is equal to 0 and we're looking for an x, that's an X-Intercept. Hang on, when y is equal to 0 and we're looking for x, that's an X-Intercept. So that's what this is. The zero of a function could be interpreted as the X-Intercept. So watch. So here's a function. F of x equals 4x minus 7. Find the 0, please. But students do get confused. Listen, I say find the 0 of this function, and what they'll do is they'll plug a 0 in for x. That's not it. And I mean, it's the other guy. It's the other one. Plugging a 0 in for x is not what I want. To find the 0 of the function, it's whatever makes the function equal 0. So it's like you're setting this function, you're setting the y equal to 0. You want to know when does this function equal 0. So that's, and then you solve for x. So you're solving an equation, and you move the 7 over and you divide by 4, and the answer is 7/4, I guess. That's the 0 of the function. It's also the X-Intercept. Are you guys okay? It's just a new word, but it does confuse students. It makes students do the wrong thing. When I say find the 0 of a function, they tend to plug in a 0 for x, and that's not right. You're plugging in a 0 for y, really. Yeah, they do some funny little word problems to you maybe in section 1.5. You know what? I think I'm going to quit today. I could ease into 1.6 and 2, but I'll wait till next week. We're okay. Let's just quit now. Thank you for listening. Thank you for paying attention and working.